Here's another use case. We are going to learn how to build a real-time GDPR data lake. This architecture combines the streaming part along with the GDPR-based use case. And before we start, you can feel free to scan the QR code you see on the screen to check out all the commands and the code that I'll be using in this demo. Going into the architecture, first we will create an account using the Kinesis data generator. Kinesis data generator is an open source tool that is used for writing mock data to your Kinesis streams. And we will send this mock data to our Kinesis streams, which will then be picked up and processed by our Glue streaming ETL job using the Iceberg connector. And we will write this data into the Iceberg table. And this data can be queried by various tools, including Athena, and the metadata will be in the Glue data catalog. So let's look at the solution in action. So here are the steps involved for the solution. And I have completed most of them so that I can save some time here. So the first one is you need to create a Kinesis data generator account. And like I said, this is the generator that is used for creating mock data. And you can find the instructions here, which I have provided the hyperlink, and you can find this information in the GitHub repository as well. And now going back to the Kinesis data generator, and this is, I've logged in as a user and I've selected the region US East 1, and I already have a Kinesis data stream in my account. So this is a demo data stream. I'm going to choose that. And I can choose the number of records per second, which I'm keeping at a constant of 100 records per second. And coming down, this is the record template. So this is like a schema. How your data gets generated. This is your mock data schema, basically. So I've entered the schema, which again, you can find in the GitHub repository, and I'm going to go ahead and test this template to just see how the sample records look, and you can review if the records are to your liking. And once you validate that, you can start sending data to your Kinesis stream. So you can see it starts producing data, mock data to our Kinesis data stream. And this is our data stream that I'm using. All right, next is I have an empty bucket and S3 prefix. And I'm going to use Athena to create a table on top of this, right? And before I do that, I'm going to also download the AWS Glue data connector for Iceberg from the marketplace here. So you can copy this link and paste it. And you can see this AWS Iceberg connector. And if you continue to subscribe, if this is your first time, it will ask you to accept some terms. And once you accept, you'll be subscribed. But I'm already subscribed to the software, and hence I see this message. And once you're subscribed, you would continue to the configuration and choose a fulfillment option. Choose Glue 3.0 and a software version of your choice and continue to launch. And if you go to the usage instructions here, you can activate the Glue connector by clicking on that link, and it'll take you to that page. And you can name your connector. That's it. Go ahead and create the connector. And you can see the connector that we have created here. It's from the marketplace. Now let's go to the Athena and create the table. I've already created the table here. So this is the Iceberg table I'm going to create, and this is the table that I'm going to use for my GDPR. And this is the Kinesis record. So it's basically going to have the same schema more or less. And this is the location of our ETL output. So our Glue job will basically read the data from our Kinesis stream that we are inputting from the Kinesis data generator. Is going to do some basic ETL and write the output in this location. And the schema is of that output files. And you can see the table type is Iceberg. So these are the most important values. So let's go back to the glue, and let's go ahead and run this job. So here is the job that I've created. If I go to the Glue Studio and click on the jobs, you'll be able to see that I've created a job called demo job. And let me walk you through the script here. And this script will basically, it's a Glue streaming script. And before I run this, I will need to configure the Glue catalog, sorry, the Spark SQL catalog to use Iceberg. So here, for instance, I'm using Glue catalog as my catalog for Iceberg. And also I'm instructing Iceberg to use S3 file IO. So these are the important configurations. So if I come down, you can see I'm just applying some schema and I'm writing to the Iceberg table, right? So I'm reading from the kinesis and I'm writing to the Iceberg table. I'm getting the kinesis on here. And you can see the type of data is kinesis as well, and the connection type is kinesis, right? And the window size is 100 seconds. So we have written this job, like you can find the GitHub repo as well. And if you go to the job details, you can see that the type of the job is Spark Streaming, and the Glue version is Glue 3.0, and language is Python 3. And we are selecting a G0.25x worker, which is a smaller worker, and I've enabled auto scaling. It's always best practice to enable auto scaling, especially for streaming jobs, right? So you don't want any idle workers to be up and running. And I set the maximum number of workers from 2 to 5. And going into the advanced properties, first you need to specify the connector that we got from the marketplace. So I've chosen the connector. And after that, you need to select, you need to enter these job parameters, these job properties. So I have provided what job properties you need to enter here. Basically, you need to provide a catalog path for storing your Iceberg warehouse. And also you need to provide the output S3 path, which is same as the table, as the bucket you created on step 3. And you need to provide your kinesis on to identify your kinesis data stream. And also you need to set user jar equal to true. So that's about it as far as configuration goes. Now you can go ahead and run this job. I've already run it and the status is running. Since it's a streaming job, it's always going to run. And it's going to like read inputs and it's going to do the ETL on the fly and write the output to the S3. So this is our S3 location because data is our prefix. So if I go inside, you can see the data and the metadata. And if I go inside the data, you can see all these hash prefixes. This is using the object storage location provider. And it's going to help with the S3 scaling, traffic scaling. So even if you write huge number of records, which happens with streaming, and spreading it out across multiple hash prefixes really helps with S3 performance and also helps mitigate S3 throttling errors. And if I go inside each of those hashes, you can see the Parquet fans. Now I'm going to go back to Athena, and you saw as of now how to handle Glue streaming using the Iceberg connector. Now we're going to go back to Athena and work on the GDPR. So here I've already created the table, the customer table, like I said. Now let's go ahead and run some GDPR here. So first, let me get some customer IDs. So let me pick the first one. You can see the count is 1. Now, a merge query. What we are doing essentially is deleting a record, this particular record from this table. When the records match, you're deleting it. So that's what we're doing. Now we have deleted. So let me query, let me run the same query again. Now the count should have changed from 1 to 0. You can see right now the count is 0. Now let me run this query and get another customer ID. Let's use that to run upserts. So here, let's get the first one. Let's see what is the phone number for this customer ID. So you can see the phone number is this. Now let's go ahead and use the same merge into query. And let's set the phone number to 000. It completed. Now let's go ahead and select. The phone number should have updated to 000, as you can see here. Now, the last step is to vacuum our table. It's always a good idea to run vacuum on your Athena Iceberg tables, and Athena makes it very easy for you to clean your old snapshots and metadata files that are not needed anymore. And it is highly recommended that you run vacuum on a frequent basis, especially for use cases like streaming, right? It's going to create a lot of metadata files and a lot of snapshots. So it's always a good idea to run vacuum on a periodic basis. So it's as easy as just running the query. It's going to take a while and going to complete. It completed. So that's about it for this demo. You can add more things into here. You can make it as rich as your use case calls for. But this is the basic GDPR use case with Athena and Blue Streaming.